In this ANSYS tutorial video, we will be looking at Lab 3, question number 3. Before we get started, we first have to determine which units we're going to use throughout this question. And looking at our example, our best option would be to use the SI column of the table of consistent units, converting all of our gigapascal values into pascals and all of our centimeter distances into meters. Next, we can determine which type of element we are going to use in this question. Looking at this model, we can see that there's two plates that don't have a thickness specified. So for this model, we will use the solid element type. In terms of material properties, we have two sets of material data that we have to enter in. Our first set of data, which we will name ID number 1, will contain all the material properties of copper, its elastic modulus, Poisson's ratio, and its thermal expansion coefficient. We will do the same for material ID number 2, which in this case will be our magnesium alloy, and we'll enter in its respective values for elastic modulus, Poisson's ratio, and thermal expansion coefficient. In terms of actually creating the shape of our model, we can see that there's two rectangles that are separate from each other. So when we model it, we're going to create two rectangles and assign each of these rectangles its respective material data. Another thing to note is that in this example, these two plates are combined with one another. Therefore, we will have to utilize the glue command later on in this example. And under meshing is where we'd actually enter in which plate has which property ID. So the way it will end up working out is this top plate here will end up having the material ID number 1, and this bottom plate here will have material ID number 2. In terms of constraints, we simply have a displacement of 0 along the two lines right here. So we'll have to specify that all degrees of freedom equal 0. Next, in terms of loads, we have a temperature change of positive 40 degrees. So we'll just set our initial temperature to 0 degrees and our final temperature to 40 degrees. Note that you can pick any two temperatures as long as the initial to final is a 40-degree increase. Alright, so we can go ahead and open up ANSYS right now. So to get started, we are first going to create our element type. So under preprocessor element type, we are going to create a solid model type. Make sure a node is selected. Click OK. And since there's no thickness associated with these two plates, we don't have to specify plane thickness, so we can go ahead and just click close. Next, in terms of defining our material properties, we're going to have to define two separate sets of data. So under material properties, once again, we're going to open up material models. Under structural, linear, elastic, isotropic, we're going to enter in our elastic modulus and our Poisson's ratio for our copper alloy. And to enter in our thermal expansion coefficient, we're going to close down the linear tab and we're going to open up thermal expansion and secant coefficient, isotropic, and we're going to enter in the value that was given to us. Alright, so now that we've defined our first material ID, we can go ahead and create our second material ID. To do that, we are going to open up the material tab here and click on new model and material ID number 2, click OK. And now notice here how we have a second tab opened here, which is our second set of data that we can enter in. So our first set of data is up here if we ever want to change it or access it, and our second set of data will be located right here. So going back, we have to enter in our elastic modulus and Poisson's ratio for this new material. So we're going to open up linear, elastic, isotropic, and we're going to go ahead and enter in the new elastic modulus and Poisson's ratio. And we can go ahead and repeat this step again, this time entering in our thermal expansion coefficient. can go ahead and close that down. And we can move ahead and create our element shape. So under modeling, create areas, rectangle by 2 corners. And our first rectangle, going off the dimensions that the question gave us, is going to have a length or width rather of 0.05 and a height of 0.001 meters. And our next one will we'll start at the origin once again and have a height of width of 0.05 meters and a height of negative 0.001 meters. Alright, so now we have our shape properly drawn out. We can go ahead and glue these two areas together. So what glue does is whenever two materials are in contact with one another, glue basically attaches them to each other. This is different from add because add will just add those two areas together and create one big area, whereas glue keeps those two areas separate but attaches them. So under operate, we're going to open up booleans and we are going to click on the glue tab and areas, and we're just going to select the two areas on our screen and click OK. So now that they're properly glued. So for meshing, we're going to open up our mesh tab, open up mesh tools, and we're going to select element attributes to areas and click set. We're going to click on the upper area this time, click OK, and we want this upper area to have the properties of copper in our example. So copper was defined as material ID number 1. So make sure that number 1 is selected in this box right here. We can go ahead and click OK then, and we're going to repeat this step for the lower area this time, making sure that material ID number 2 is selected because magnesium was given material ID number 2. We're going to click OK, and now the ANSYS knows that the top area right here is copper and the bottom area has the properties of magnesium. We can go ahead and set our size controls. So under areas, set, and we're going to select all our areas, and you can choose however big you want your size to be of your elements. I'm going to choose this value right here, but once again it is up to you. And we're going to click on mesh, click on our areas, and OK. So now we can go ahead and apply our constraints to our model. So under the Solutions tab here, we're going to open up Define Loads, Apply, Structural, Displacement, and On Lines. And we're going to make sure that the two lines in the corner here are selected. And we're going to apply a all degrees of freedom constraint with a displacement of 0. Click OK. And now our model is fully constrained. We can go ahead and apply our thermal loads to it. So under the Settings tab here under Define Loads, we're going to specify our uniform temperature, which is our final temperature. So we want it to be 40 degrees. Click OK. And we're going to specify our reference temperature, which is our initial temperature, which will be 0 in this case. Click OK. So now that the thermal load is applied, we can go ahead and click Solve and current LS. Click OK. And our model is fully solved, and we can go ahead and extract the data from our model.